Hey guys, I just wanted to put together a video that went over how I would approach doing the problems in the PowerPoint for the group frequency distributions. So the first thing, I don't know if it'll work, but you can try. What I do is I just copy and paste into, oh, it did work. I just copy and paste into Excel from the PowerPoint, and you can reformat the numbers so they're not so huge. But basically what I'm going to do is instead of having my groups combined here, I'm just going to, I think I need to reformat. Oh, no, it's set for 12. Okay. What I'm going to do is just set this side as my lower bound and this side as my upper bound area of my peak power output values. Okay, and this is in watts, right? So I'm going to say 600, 750. I've identified some type of numerical pattern, and then I can do the same thing for this side. 749 to 899. Identify a pattern, and we should end up at 1649, which is correct. Okay. My cumulative frequency, these didn't pop up obviously because they are inserts on my PowerPoint. So again, the way that we go about calculating cumulative frequency is we say from the worst score, what is the frequency, right? So in this case, the lower power output means you had less peak power output. So our frequency at the lowest grouping is 8. And then from there, what we do is we just say, let me make sure these numbers are the same size. Okay. We say 8 plus, right, the frequency of the next group would be the cumulative frequency of the next group. Okay, so the easy way that we can do this, similar to your activity, is you say cumulative frequency or existing cumulative frequency plus the frequency of the next group, and we get the cumulative frequency for 750 to 899. Basically, we can copy this function downwards, and you'll notice these numbers are identical to what is over here. Boo wants to play right now, but anyways. Okay, so from here we can calculate percentiles based on some raw value, right? So I think the way that I want to do this is we're going to say a raw value of 675, 1000, and 1380. Okay. And then from that, we should get some percentile for that raw score. Okay, so the way that I like to do this in Excel, and I explain this a little bit better in the activity, is that you're building an equation. And remember, order of operation is really important, which is why I like to do mine in Excel, because it's a little bit harder to make a mistake versus if you were doing your calculations on a calculator. So I'll show you how I build it gradually. The first thing we have to calculate is this part in the numerator, right? And the first thing within that numerator that needs to be calculated is the numerator of this fraction, okay? So the first thing that needs to be in parentheses is the raw score minus the lower bound that raw score, or lower bound of the group that the raw score lies within, right? So our raw score is 675 minus the lower bound that it falls within is between 600 and 749. So the lower bound would be 600, right? And we can type this or we can use cell references, which I think I would rather do. Okay, so 675 minus 600, okay, that's going to be divided by the interval size. Remember that interval size is the difference between two adjacent lower bounds or two adjacent upper bounds. And you can use that with any of these numbers as long as the values are adjacent groups or right next to each other. So I'm going to do 750 minus 600. That should give me a difference of 150. Once you find your interval size, it's constant, so we can actually type that number. Okay, so now we have this first part, right, this subtracted part being calculated first, and then we're dividing by our interval size. Okay, all of this has to be done before we can multiply by f. So we need to surround this area with more parentheses. Okay, so now we have two parentheses at the start. That's kind of how you keep track for this type, or for this particular equation. Okay, we then have to multiply by the frequency of the group in which 675 lies within. So that would be 8. Okay, and then we add the cumulative frequency of the group that is worse than the group that 675 lies within. Well, if you think about it, if there's nothing worse than this group, cumulative frequency, we don't ever talk about it, but it starts at 0, right? Because we're saying nobody exists at the 0th percentile. And then we work our way up to what we would consider the 100th percentile, right, within a given distribution. So basically, cumulative frequency is 0, and we can do the same concept where we say, okay, 0, or current cumulative frequency, plus the frequency of the next best group is equal to, and that's usually how we get the frequency and cumulative frequency in the worst group as the same number. Okay, so in this case, our cumulative frequency would be 0. Okay, and then we put a parenthesis around that to enclose this whole top part. So that means we need to add another parenthesis at the front of our stuff. And you can see these colors of the parentheses change, right? So it's saying the innermost one, these purple ones, are being calculated first, and then the red ones are being calculated after that, and then the black ones after that. Okay, all of this is going to be divided by the total number of participants that we have in this distribution, which we could put as a cell reference of 90, but it's similar to the interval size where it's a constant, so we can just put the value into our formula. Okay, we can add an additional parentheses around here if we want to do the step where we multiply by 100 to get our actual percent. Okay, from here we can then say I want to decrease my values, let's say to the 10th decimal place, right? And we would argue that a person in this given distribution, right, with an output, a power output of 675 would be at the 4.4th percentile, right? Or they performed equal to or better than 4.4% of the people in the distribution. Okay. All right. So then if we do a same procedure for 1,000, right, we can copy down here, and then all we have to do is drag our cell references. Okay. So 1,000 is going to be this blue box. The reference of the lower bound is in the red box. So 1,000 lands between 900 and 1049. Okay. Our interval size is still 150, so that stays constant. The purple box, C6, right, or where it's at C6 right now, should match, should match our frequency of the group at which 1,000 lies within. And then instead of 0, we can put a cell reference to the cumulative frequency of the group that performed worse than the group where 1,000 lies. Okay, our sample size is still the same. We're still multiplying by 100, so you should be able to get a percentile of 35.6. Okay, so person who performed a peak output or had a peak output of 1,000 watts, right, within this given sample distribution would be considered at the 35th percentile or 36th percentile approximately, or they performed equal to or better than 35% of the people in that distribution. Okay. For this last one, since I do have a camera recording, I still wanted to at least give you guys an idea if you're writing stuff out instead of using Excel. Okay, it's just a cautionary thing to remember that you have to use your parentheses very liberally. Okay, so if we were writing this out, again, our raw score in this case is 1380, right? So our percentile would then equal 1380 minus the lower bound at which that value falls within. So that's between 1350 and 1499. Okay, so we have 1350 as our lower bound. Our interval size is still 150. Okay, times the frequency of our grouping that 1380 lies within, right, which is going to be 10. Plus the cumulative frequency of the group that performed worse than the group that 1380 lies within. So that would be 76 if my vision serves me correctly. Our sample size is still 90, right? And then we would multiply whatever we get out of this by 100. Okay, so if you're doing a written example or if you're doing it in writing, again, the first thing you'd put in your calculator is the fraction, right, in the numerator. So you'd do 1380 minus 1350 divided by 150 times 10 plus 76. That sum, or that amount divided by 90, that amount times 100. Okay, this is why I like Excel, because the calculations are, I don't know, I think they're a lot easier to accomplish, and I think I just messed that up. As I said, it was so easy. Hold on a second. Oh, we double click this. What did you do, Natalie? This should be 1200. Okay. Oy, yay, yay. Okay. So we drag our boxes where they're supposed to go. Generally, once you understand what the pattern looks like, I'm pretty good to go, right? And so then we could identify that a person who had a raw score of 1380, right, or peak power output of 1380, in this sample distribution would be at the 86.7th percentile. Okay, so hopefully that makes sense. Hopefully you got those same answers. And if you have questions, please let me know.